Welcome to another lecture module with your favorite instructor, me, of course, and today we're going to be talking about substitution reactions. Now, I'm going to be honest with you, I'm not going to be your organic chemistry instructor right now. What I am going to be, I'm going to be your personal relationship counselor. That's right, that's what I said. Who would have ever thought that you would have gotten this kind of discussion about the organic birds and bees in this class? Well, what do I mean by that? Well, this lecture is going to be focused on something that we call substitution reactions. And here's why, folks. Imagine that you're in a relationship. You can be substituted. You can be substituted for anything that walks across the street. Can you believe that? Well, molecules are the same way. We just have to figure out who's the cheater. That's the only thing that we've got to do. And I think that we'll be okay with this lecture module if that's what goes on. So substitution reactions, something has to be substituted. Well, what's going to be substituted? We're only going to be focused on the alkyl halides. That's it. So an alkyl halide is an alkyl group, methyl, ethyl, propyl, isopropyl, butyl, pentyl, hexyl, heptyl, with a halogen on it. That halogen is a fluorine or a chlorine or a bromine or an iodine. But we've already kind of discussed that chlorine and bromine are going to be the most common because, number one, fluorine is just too darn reactive. I mean, explosive relationship there. Nobody wants to be in a relationship with fluorine. It's crazy. And then iodine, sorry to break it to you, iodine, but you're just too big. You're just too big. It's not going to work. You got to go. Yeah, these molecules are very superficial, folks. These molecules are all about prettiness. They're all about attractiveness. It doesn't matter what's on the inside. It matters what's on the outside. And they're just not physically attracted to iodine. And that's exactly why it is too large on the molecule. So we need to talk about substitution. We need to talk about, in terms of halogen, what gets substituted, why does it get substituted, and so forth. But before I do this, again, I gotta be your relationship counselor. So let's say that this is you, right here. Ta-da, there you are. You can put a dress on it if you want to. It doesn't matter. Whatever floats your boat. And let's say that you are madly in love with the other. That's what I'm going to call this one. This is your significant other right there. Oh, how sweet. And you spend time together. You go out and eat together. You go to parties together. You go to the bars together. You go to each other's parents' house. I mean, this thing is kind of serious. And then let's say one day you're just feeling bad and the other wants to go out and have some drinks with some friends. Okay, I kind of see where this story's going. So they go out and they go to a bar, and I'm going to call this the evil one right here. Ha ha ha. Because guess what's going to happen? The other, your other, will go to the bar or go to the restaurant or go on that work date or maybe go to the gas station. Maybe that's where the evil one resides and lies. And they go to this place and they look at the evil one in your eyes. And folks, they begin to madly fall in love with each other. Oh, another love creation story is going to be happening here. But the question, what type of significant other do you have? You've got two options here. Number one, your significant other could go out, see the evil one. They fall madly in love. But before anything serious happens, your significant other comes back and they say, listen, it's just not going to work. I'm sorry, but this is over. I'm not going to waste any of my time. I'm not going to waste any of your time. We need to just split ways. You go your way, I'll go my way. And then they end it. And then they go back to the evil one and they fall madly in love and have a product baby. That's option number one. So in this route, one will end it first. And then they'll go and form a new relationship. Is that the type of significant other that you have? I mean, we all hope that that's the type of significant other that we have, if it's going to happen. I mean, you hope that this would never happen. But if it does, you would just plead for honesty. Just come to me and tell me that it's not working and just end it. And then you can go do whatever you want to do. But that way, you're not tying me up into this whole love triangle loop. I don't want you to be cheating on me behind my back. That's option number one. Molecules are the same way, folks. I'll talk about that in just a minute. All right, so option number two. Option number two is the dreaded cheater. No one wants a cheater. What that basically means is that you've got this relationship going on, and then they go out on that date. They go out on the work date. They go out or stay late. Who knows what they're doing? Do you know what they're doing? And they begin to associate with the evil one, and then things get a little happy fingers. And before you know it, something serious has formed between the other and the evil one. But at the same time, folks, the other did not come and tell you. You have no clue. You have no clue that that is actually happening. So the other, in this case, is a cheater. It sees both things at once. Yeah. They wake up, kiss you bye. Have a good day at work, honey. Bye-bye. And off they go. And then when they get to work, they maybe are seeing someone else at work, or meeting someone at lunch, or meeting someone for after work, quote, drinks. And then they come home to you a little bit later and you have no clue what has happened. Molecules are dirty that way. You can't trust some of them. So the reason I'm giving you this, folks, this is exactly what substitution is all about. What is getting substituted, and how is it happening? Is the molecule going to tell the other counterpart that things are over? Or is that molecule, that part of the molecule, going to tell its other counterpart, I'm not going to tell you that I'm cheating. I'm going to take some time and figure it out, and then I'll make up my mind, and then I'll let you know after the fact. Well, you can see there's two options up at the top. Well, I'm going to call this option 1 and option 2. Don't associate number 1 with number 1, number 2 with number 2 yet. All right? But there's two options, two routes of substitutions. You now know what they are. The two choices from up above. We label these with a big S that's out in front, and the big S stands for substitution. Again, we're lazy. We don't like to write out big, long words. And then we'll write a small n down here at the very bottom. And the N stands for nucleophilic. Folks, this is something that we have talked about all semester. Nucleophile and an electrophile fall madly in love. A reaction happens and a product baby forms. I mean, this is something that we've said over and over and over. Well, we're still focused on nucleophilic activity. We're still focused on the nucleophile. So this SN1 and SN2 stands for nucleophilic substitution route 1 and nucleophilic substitution route 2. A lot of people want to know what the 1 and 2 stands for. It is not really option 1 and option 2 up above. All right? Don't start associating that yet. But number 1 and number 2 really refer to kinetics of the reaction. So in general chemistry, when you were taking maybe the second part of general chemistry, you got to a section about kinetics, about speeds of reaction. And we had first order and second order reactions. First order and second order reactions happened in a different way. I'm not going to get into the details here, but that is what it actually refers to. We are not general chemistry. We're not computational chemistry. We're none of that. We're organic in this class, and I want to keep it at the organic heart. But that is what the number 1 and the number 2 stands for. If you're curious, it stands for kinetics. What is the kinetics like of the reaction? All right. So here is your introduction to substitution. Substitution, we have a molecule, right up here at the top. They're madly in love. And that molecule has a piece. And that piece, you got to keep your eye on it. That piece can cause you trouble. That piece of the molecule, it can do some crazy things, and it can be loyal. It can say, no, I'm staying with you for the rest of my life. Oh, how sweet. Or that piece could say, you're just not doing it for me anymore. So I'm going to leave you, and I'm going to go off on my own, and I'm going to open you up so that way you can have another relationship with someone else if that's what you want. And that is a very clean breakup. That is what we all hope for. Molecules kind of hope for some of that too. And we do have some very good carbons that behave that way. Those carbons make great boyfriends or girlfriends. And then we have some carbons that are going to be a cheater. We have some carbons that will go out and kind of grab onto the molecule that they're currently on, or a group. And then it will also take a look at the other piece as well and say, I like you too, though. And it can't really make up its mind. Those carbons are cheaters. They see both groups at the same time. We don't want those in our relationship, but sometimes molecules are okay with that. That's kind of crazy, isn't it? But that's the way that it is in the world of organic chemistry. Before I go further in substitution, I also want to introduce you to the next lecture module topic, because these two go hand in hand. So here I've got a molecule, and this is my organic, of course. And this has the X on it, so this is the halide. And then this Y group is typically our nucleophile. All right, that's what we called a nucleophile this whole time, in this whole semester, something with a negative charge. So 2 routes can happen here. A substitution reaction can happen, and that's great. We're getting ready to be talking about replacing. My other is getting ready to replace me. I know it's kind of depressing, but folks, that's just the way that it is. So these are SN1s and SN2s. All right, so SN1 and SN2. 2 routes, 2 modes of mechanism that this can happen. However, if you can imagine, a relationship story is the same as this. When that breakup happens, folks, sometimes you're just not ready for another relationship at that moment, right? You want to take some time. You want to kind of look back and say, I want to make sure that I have my life together before I jump into another relationship automatically. And for some of these molecules, that is a better option. They just kind of want to be on their own. They don't want anything else to come in at that moment. So that way they can focus on themselves. They can create, if you want to think of it, a stronger bond with themselves. And this is what we call an elimination reaction. And elimination also takes place in 2 different routes, and we call that E1 and E2. All right? This lecture module will only focus on substitution, which is up here at the top. 2 modes, 2 ways of action. The next lecture module, which is probably how we end the semester, is going to focus on elimination. These molecules are going to be looking out for themselves. They're going to be looking and saying, I need to work on me before I get into another relationship with someone else, because this was traumatic. And maybe I don't want to take that gamble again and have this happen to me one more time. So an elimination route can happen, and there's two modes of mechanism, E1 and E2. And that is what the next lecture module will completely focus on. Right? Now, more terminology. I told you that organic chemistry is a world of vocabulary. It's a new language, and here we're talking about the love language. So what about these groups that leave? Well, the groups that leave, we're only going to be focused on a few of them, and those are the halides. I mean, that's why we said substitution of alkyl halides. And we're going to call these leaving groups. And this is how we're going to start first. We're going to start with molecules that have halogens. Those have very good leaving groups. Why? Well, folks, all of this is based on electronegativity. And electronegativity, the highest electronegative atom is fluorine, and then chlorine, and then bromine, and then iodine. Right? And we said electronegativity goes down as you go further down the chart, and it decreases as you go to the left of fluorine. It gets less and less and less and less. So fluorine is going to have some predisposition that we're going to have to start learning. But again, fluorine, too explosive. Chlorine and bromine are good. Iodine's just too big. That we've said before already. But chlorine and bromine are very good leaving groups. What that means is that they're kind of ugly. I told you, molecules are very superficial. It's all about what's on the outside. Chlorine and bromine are very ugly on a molecule. Nobody wants it. I mean, you know, they probably have warts, hairless, missing teeth. Who knows? Maybe they're, you know, well, you get the idea. So if they can go out and if these molecules can replace and substitute that old nasty, ugly group, chlorine and bromine, onto a molecule, then the molecule's going to be much happier. And it's going to say, listen, you toothless, wart-infested, hairless thing, you got to go. I'm over it. I found somebody else better. I've brought them in, and they are my new relationship now. Sorry, bye-bye. And away chlorine and away bromine will go. We call that a leaving group. Now, if these are very good leaving groups, that means they're very ugly. Very, very ugly. Iodine is one of the best leaving groups. Nobody wants iodine. Poor thing. I feel sorry for it sometimes. Bromine and chlorine's not that far behind. So substitution reactions are going to focus on the halogen group. The halogens, in particular, chlorine and bromine, is what we'll be using most of. The reason chlorine and bromine are very good leaving groups, and they can be replaced with many different things. Which means that if I had an alkyl halide up here at the top, and I react that with another nucleophile, something a little bit prettier, folks. That's all that it takes, just a little bit prettier. Then this new nucleophile will come in and attach and kick that bromine out. I told you it's a sad story. But these are the molecules, and this is their love interest between each other. It's how it works. And the questionable thing here is, what does this carbon do? The carbon that had that ugly, nasty, warty, toothless halogen, what does it do? Does carbon say, halogen, it's not working for me, you got to go, and then bring in that nucleophile? Or does carbon look at the halogen and say, hey, I think this is going to work. I love you. And then that same day go out and form a relationship with the nucleophile and see both of them at the same time, the halogen and the nucleophile, and then take its time on figuring out which one he or her or she likes the best. And then make up his mind or her mind on what to cleave, how to end it, and which one to kick to the curb. All of this is due to electronegativity. Again, we've talked about it. Keep in mind that electronegativity, it's not shared equally between the carbon and the halide. The carbon and the halide, let's say chlorine, right? Chlorine's got these free dots around it. This carbon is on a molecule. It can be a longer molecule. I don't care what it is, but there's a carbon there. Folks, this bond right here is polar, isn't it? It's something that we talked about back in lecture 1. Free dots. Chlorine's electronegative, more electronegative than carbon. So we said that we could assign polarity by drawing an arrow like this, and we see an equal charge distribution. And we see, maybe for a moment in time, this carbon having a squiggly positive and this chlorine having a squiggly negative, a partial positive charge and a partial negative charge. When this begins to happen, we have a lopsided relationship. Chlorine is demanding more, maybe, than what carbon can give. And in addition to that, chlorine is ugly. What would you do? You had someone that you were not attracted to at all in a relationship that just wants and wants and wants and wants and wants and wants and wants. I mean, come on now. You're going to suffer through that? No. You're going to put yourself out of misery. And you're going to say, chlorine, you got to go. See ya, bye-bye. I found a new love. Where does that love come from? Well, it's going to come from another nucleophile that we abbreviate with a Y that is negatively charged. That nucleophile, and we're going to be able to talk about plenty of them because we've seen them now over the course of the past weeks and weeks. This carbon, which is partially positive, can be attracted to that nucleophile, which carries a negative charge. The issue is, what does carbon do? Does carbon cleave the bond with chlorine, become single, and then say, nucleophile, I love you, come on? Or does carbon be sneaky and cheat? Does carbon grab onto chlorine, and does carbon grab onto the nucleophile and says, oh, I love you and I love you too? And then make up his mind on, or her mind, on which one needs to be cleaved. That's the difference with the substitution reactions. That is the difference between SN1 and SN2. And throughout this lecture, and throughout the next lecture, these nucleophiles are going to be labeled with a Y. So folks, that's where I'm stopping this video. I think we've had enough love talk. And in the next video, we'll pick up from this topic. And we'll continue on with substitution reactions. And we'll introduce maybe some new vocabulary that we haven't learned yet. More that we haven't learned yet. And we'll pick up from there. All right. So, I hope I've not ran you away. I hope that I've not made you question your own relationships that you're having right now. But keep in mind, you want to be a stable molecule no matter how this happens. And you just hope that your carbon is not a cheater. All right. I'll see you next.